right, so section 9.5 is on solving rational equations and inequalities. So we learned how to do this at the very beginning of the year, how to clear fractions at the very beginning of the year. So it says in order to solve rational equations, we multiply each term of the equation by the least common denominator. So we could do things the long way, right? And we could get all of them to have the same denominator and then solve the equation just using fractions throughout the problem. But we don't really like doing that, right? We don't like to keep fractions throughout, and if we can clear them, it's just a lot easier for us. So we're going to clear the fractions. So if we look at number 1, our least common denominator, if I did change them all to the same denominator, they would all be 12. Did you guys see that? So what we do is we multiply every single term by 12. So a lot of times I kind of shortcut it and I just put a 12 on the outside, and then I just know that that's going to go into every single thing. Now for this first one, I'm going to go ahead and show you multiplying 12 into everything. And I probably won't write this step every single time because it gets a little bit annoying writing it out, especially when we have our x's. It will be really long. Okay. You see it? Yeah.
Why couldn't you just multiply 1/2 by 6 and then...
Yeah, so you could. So you can multiply by like 6 over 6 and 2 over 2. Yeah, so you could get common denominators that way, and then you can just keep fractions throughout. You could do it that way. But I kind of like to get rid of the fractions if possible. I don't like writing my whole thing like x over 12 plus 6 over 12 equals negative 2x over 12. But you can.
Then could you multiply it out by x? Or by 6?
Oh, and then you can multiply through by 12. Yeah, totally. Yep. Yep, exactly. Okay, so if you're at this step, then when we take our 12 times x over 12, do you guys see how they would cancel? Jacob? You're not gambling back there, are you? Taking bets with your cards back there. All right, so then the 12 and the 2 reduce out to 6 and 1. So we get 6. And then equals, and then the 12 and the 6 reduce out to 2 and 1. Joey, you with me? So we get 2 times negative x is negative 2x. Okay, then we get everything on one side. So I'm going to subtract the x over. So I get negative 3x equals 6. And I divide by negative 3, divide by negative 3. So your answer then is negative 2. Okay, and that's it. Okay. So let's do that on this one. So if I was finding the least common denominator, do you guys see what the least common denominator would be? Yeah, just 8. So we would multiply everything through by 8. So now I'm going to try to get away from writing out that step where I have the denominator every single, like when I take 8 into every single thing. So I'm going to take the 8 into the first one, and when I do 8 times x over 4, I'm going to take my fingers and I'm going to cancel things with my fingers, but I'm not going to cancel things. So like 8 and 4, I'm going to cover them up. So cover up the 8 and the 4, and so don't cross it out like on your paper, but imagine my fingers are covering this up right now. What would they reduce out to be? A 2, right? So you would then have 2 times x. Okay, but be careful. Don't cancel them because you're going to keep using that 8 for the next one as well. Okay, so we have 8 times x over 4, and we get a 2. So I'm going to have 2 and then times x. And then plus 8 times 3 is going to be 24. And then 8 times 7 over 8 is going to be 7. Yeah. So see if you kind of get used to doing it. It's writing out very little steps, right? So we're going to subtract the 24 over. So when we do, we get negative 17 equals 2x. So x is negative 17 over 2. Okay. So how do we feel about those two? Do we feel pretty good about those? Yeah, we did those earlier this year. It's been a while, though. Okay. Yeah, Elise? Yeah, like it's like 8 over 1. Yeah, and that way you can see, okay, I have 8 over 1 times x over 4. Yeah, so if you do it correctly and you multiply by the least common denominator, you're not going to have any denominators, right? So that's one way to kind of check to see if you did it correctly. Yep. All right, so now let's get into the ones that have x's. So it's the same concept, only now we're going to have factors that involve x. Okay, so looking at x squared minus 9, in our previous sections, we talked about how to reduce out fractions, and we would factor them and reduce. Okay, so x squared minus 9 factors into x plus 3 times x minus 3. Okay, so looking at our denominators, we're going to decide what do we need if we were going to get them all to be the same thing. So the first fraction has an x plus 3 on the denominator. The second one has an x plus 3 and an x minus 3. And the last one has an x minus 3. So if I was going to get them all to be the same denominator, what would they all be? Yeah, do you guys see that? Like you would need both of them. You need x minus 3 and x plus 3. So that's going to be our least common denominator. So that's going to be what we multiply this entire thing by. We're going to multiply by x plus 3 times x minus 3. Ooh, sloppy. Okay. So on this one example, I'm going to show you as if I wrote it all out. If you guys get this and you don't want to write it all out, that's fine. Okay, so here's what we're saying. We're going to take x plus 3 times x minus 3 times the first fraction. And then x plus 3, x minus 3 times the second fraction. Let me write the x plus 3, x minus 3 on the bottom. And then we're going to take that x minus 3, x plus 3, x minus 3 times the third one. It gets to be a lot, doesn't it? Writing this all out. Isn't that annoying? We want to try to avoid doing this because it's a lot. I haven't multiplied anything yet. I'm just showing you like the x plus 3, x minus 3, and it's going to end up canceling with those two. Do you see what I'm saying? Okay, so now take your fingers, and as you go across, you're going to start canceling things, okay? And if you write it all out, then you can do the little cancellation marks if you want to. So on the first fraction, we had x plus 3 on the bottom, and we had an x plus 3 on the top, right? So we're left with an x minus 3 and a 1. So we just have x minus 3. On the second fraction, we had an x plus 3 and an x plus 3, and we had an x minus 3 and an x minus 3. So everything cancels except for that 5. And then over here, the x minus 3 and the x minus 3 cancel, so we have 2 times x plus 3. Okay, do you guys see how that works? Do you think you would be able to do that without writing out that whole middle step? You're like, not quite yet, but maybe in a second. So we'll try some. All right, so we're going to have x plus 2 equals 2x plus 6. We're going to subtract the x over, so I get x. And I'm going to subtract the 6 over, and I get negative 4. So x equals negative 4. I think it's negative 4. I took the x over this way, and I took the 6 over this way. Do you want me to show the transition steps? You get it? Okay. So yeah, so x equals negative 4 is our answer. And you can always go back and check if you're confused. Okay, good. Caleb, you with me? Totally. All right, so this next one, looking at our denominators. So I have 2x minus 4. So it factors into 2 times x minus 2. Okay, that's going to be important to us because we didn't want to go too big. So it's kind of like, you guys remember when we had denominators that were like 8 and 16 and 32. We don't want to multiply 8, 16, and 32 by each other to get a common denominator. What would our common denominator be? 32. Just the 32, right? It's the least common multiple. So that's kind of similar on this one. We don't want to use 2x minus 4 and also x minus 2 to create our denominator because 2x minus 4 has x minus 2 within it. Okay, so now looking at our denominators, we have 2 times x minus 2. Nothing is the denominator here, so like a 1 and then an x minus 2. So what do we need as our least common denominator then? We need both the 2 and the x minus 2. We need both of them. So we're taking all of it and we're going to multiply by 2 times x minus 2. Whoops. It still wants to move, doesn't it? I'm like too close to the top there. Here we go. Okay, so let's try doing it without writing out every single step. So we have this 2 times x minus 2, and it's going in here, here, and here. Okay, so this is where I was saying take your fingers, but don't like cancel with your pen. Okay, so when we take 2 times x minus 2 times the x over 2 times x minus 2, do you guys see how this cancels and that cancels? And all that we're left with is x. Okay, so we have x because we just said that this part here canceled with this part here on that first step. But we're not actually canceling as we still need that written on the outside because we're going to take it into the next thing as well. So now on the next one, we have 2 times x minus 2. It's not going to cancel with any denominator because it was just a 1 on the denominator, basically. So it's like over 1. So we get 2 times x minus 2 times that negative 2. It's like all that. And then we have our equal sign, and now we have that x minus 2 on the bottom, so the x minus 2 is going to cancel with that x minus 2, and we're going to be left with 2 times 1. So we get equals 2. Do you guys follow? Do you guys understand that? Okay, so we have x minus 4 times x minus 2, so I'm going to distribute that negative 4. So x minus 4x plus 8 equals 2. And I continue to solve, so I get negative 3x plus 8 equals 2. So negative 3x equals negative 6. So x equals 2. Okay. Does this make sense so far? Now this one's a trick question. The answer is actually not 2. Yeah, anybody besides Nick? Does anybody else know? Yeah, Christine, what do you think?
Because x minus 2 is the
Denominator?
denominator, and it can be 0 because that is undefined.
Right, yeah. So if you go back and check and you're like, oh, does 2 really work? Let me check in my original. And you start to plug in 2, you're like, okay, I got 2 over 2 times 2 minus 4 minus 2 equals 1 over 2 minus 2. And you end up getting 0 here and also here. Okay, that's bad. We can't have 0 in the denominator. So it doesn't actually check. So it doesn't work. So what's our actual answer? No solution. Oh, yes. No solution. Don't you love that in math class where no solution is actually a solution? Very confusing. All right, so that's our answer. So just make sure that it didn't make your original denominator 0. So just quickly go back and make sure. So like negative 4 on the last one on number 3. You can tell negative 4 doesn't make any of those 0, right? So that one's good. All right, do you guys want to try number 5 first? See if you guys can get it. So factor x squared minus 1 into x plus 1 and x minus 1 and go from there. All right, so you should multiply, well, the first denominator is x plus 1, x minus 1. So that's going to be our least common denominator, right? Both of them. So we're going to take the whole thing and we're going to multiply by x plus 1 times x minus 1. So when we do on the first one, the x minus 1s are going to cancel. And so we have a 4 and then times x plus 1. Okay, so we've removed the denominator. Okay, and then minus 2, and the x plus 1s cancel, so like this one and this one would go away. And we're left with that x minus 1. And then equals 35, and then both the x plus 1 and x minus 1 go away, right? Did you guys get that for your first step? Awesome. All right, so we're going to distribute. So be careful. The one thing that I see a lot on the test still is people forget to distribute the entire negative 2. So make sure on your paper you have negative 2x plus 2. Did you guys all have plus 2? Equals 35. So we get 2x plus 6 equals 35. So 2x is equal to 29. So our final answer is 29 over 2, or you could write 14.5 if you want. Okay, that's it. Did you guys get it? Awesome. All right, so this next one we have x over x minus 1, and it's all squared. So if we just think about that as x squared over x minus 1, and you can write squared or you can write x minus 1 times itself like that. That might help. So do you guys see what your least common denominator needs to be in this case? Yeah, you need x minus 1 times itself, x minus 1. So we're going to multiply everything through by x minus 1 times x minus 1. So in the first parenthesis, we're going to have the x minus 1 and the x minus 1 cancel. So I have 5x times x minus 1. And then I have 4 times x minus 1 times x minus 1, because there was no denominator. And then I have plus the x minus 1 and x minus 1 cancel, so I have x squared. And then you just continue to solve out. So we're going to distribute. So when we FOIL this part out, we end up getting x squared minus 1x minus another 1x, so minus 2x plus 1. Did you guys all see how I FOILed that? And then times 4. And then over here I'm going to have 5x squared minus 5x. Okay, so we have 5x squared minus 5x equals 4, and then times x squared minus 2x plus 1, and then plus x squared. Okay, and we continue to simplify. So like the 4 times the x squared part, it's going to be 4x squared minus 8x plus 4. These are like the never-ending problems sometimes. Just keeps going and going. Luckily this one, do you guys see how we have 4x squared and an x squared? So that makes 5x squared. So luckily when we subtract 5x squared from both sides, it goes away, which is kind of nice. Otherwise we'd have to factor, and that's when it really gets to be like the never-ending problem. So when we subtract 5x squared, you guys see how that will go away. So that's nice, we like that. Okay, so we're going to add the 8x and add the 8x. So we get 3x is equal to 4, so x equals 4 over 3. And then just do your quick check just to make sure. So looking at your denominators originally, 1 was the only thing that would make it undefined, so 4/3 is going to be fine. Okay, is this making sense? Okay. So the next thing that we have talks about if we have extraneous solutions. So we had one that was an extraneous solution, right? We had the one where we got x equals 2, but it didn't actually work because of the denominator. Okay, so always look for the extraneous solution. And then we're also going to have things that look a little bit strange. So number 1 is not really that terrible if you leave it as x plus 1 times 1 minus x, but look at number 2. Looking at x squared minus 9. So let's see, Julian, how does x squared minus 9 factor?
X plus 3x minus 3.
Yeah, it factors in x plus 3x minus 3. Do you guys see what's wrong when we have 3 minus x there? Yeah, so it doesn't quite look like that that x minus 3 that we want. So Ethan's saying, well, what if we like multiply 3 by negative 1? That's exactly what we want to do, okay? So it's not super important on number 1. We can skip number 1 if you want, or we can at least start with number 2. So we notice that if we factor the x squared minus 9, it's x plus 3 times x minus 3. And so we have the x plus 3, that's good, but this is 3 minus x. It's not x minus 3. So basically we know that if we have 3 minus x and we multiply through by a negative 1, we get negative 3 plus x. Well, that's the same as x minus 3. That's what we want, right? So if you ever have the opposite of what you want, just multiply the numerator and denominator by negative 1. And that's allowed because we're not changing the fraction when we multiply by the same thing on top and bottom, right? It's like getting common denominators, kind of. Like we can multiply by 2 over 2, 3 over 3, right? So when we do that, this becomes negative 1x minus 3 all over x minus 3. And that's what we wanted. We wanted that x minus 3 on the bottom. I'll leave that bottom factored, so x plus 3, x minus 3, and then equals 5x plus 1 all over x plus 3. Okay, so now it's set up how we want it, so then we can do that thing where we clear the denominators. So we're going to multiply through by x plus 3 times x minus 3. Okay, and this one does get a little bit messy, so try it along with me. This is like one of those ones where it gets a little bit weird. It involves factoring. Fun, fun. Foiling and factoring. All right, so on the first one, the x minus 3's will cancel. So kind of with your fingers think, okay, x minus 3's go away. So kind of cover up the factors that are the same. And you're left with x plus 3 times negative x minus 3. Okay, so we're going to write that. So we have x plus 3 times negative x minus 3. Or negative 1x minus 3 if you want. And then on the next one, luckily both those denominators cancel. So we're left with 3x plus 1 And then on the last one, the x plus 3's are going to cancel, and then I'm left with x minus 3 times 5x plus 1. So if you can do this, you can do anything on your homework, I promise. Okay, so we're going to FOIL it out. So I get negative x squared minus 3x minus 3x minus 9 when I FOIL it. And then I have plus 3x plus 1. And then when I FOIL this one, I get x, or 5x squared plus x minus 15x minus 3. Okay, so we start to simplify, so we're like, okay, I got negative x squared. One of those negative 3x's cancels with that positive 3x on the end, so I'm going to have negative 3x minus 8 equals 5x squared minus 14x minus 3. So this is all manageable. You guys know how to do this. You just don't like doing it. We can handle this. You're like, that's true. All right, so get everything on one side. So we're going to have 6x squared, right, when I add the x squared over. I'm adding x squared over. And I'm going to add the 3x over, so I have minus 11x. And I'm going to add the 8 over. So I'm going to have 6x squared minus 11x plus 5. So when we have x squareds and x's, we then factor. So we factor. Can you guys tell what it is? Yeah, instead of doing like the 2 and 3, it's actually 6x and x because we want that 11 in the middle, and you can kind of see the connection between the 6 and the 5. So it's going to be 6x and a 5 in a set of parentheses, and it's x and 1 in the other parenthesis, because then our outer and inner are going to combine to be that negative 11 if they're both minuses. So it's going to be a minus and a minus. So then we have 6x minus 5 equals 0, and we have x minus 1 equals 0. So add the 5 over and divide. So I get 5/6, and I get 1. And just do a quick check. Did either of those make it undefined? No, it was where x was 3 and negative 3. That was bad, right? So those are answers. Does this make sense? So really quickly, if it bothered you that you had a 1 minus x on that first example, then go ahead and multiply by negative 1 over negative 1. Oops, I don't know why I did that. Negative 1 over negative 1. Then you'd have 3 over x plus 1 minus a negative 3 over x minus 1 equals 4. And then you can even put this negative and negative and make that a plus, right? So you could rewrite that equation as 3 over x plus 1 plus 3 over x minus 1 equals 4. And then you can clear your denominators. So you can go from there. Does this make sense? Okay, so then the last little bit that we have are rational inequalities, and we're going to talk about that tomorrow, so we're going to hold off on that. So let me pause this.